Energy Switch is the popular point-counterpoint show where two leading experts with different perspectives discuss the most pressing energy and climate issues in the news today. Next on Energy Switch, we'll talk about the supply and demand for minerals needed for alternative energies.
Funding for Energy Switch was provided in part by the University of Texas at Austin and by EarthX.
All energy systems require minerals and metals, but newer energy technologies will require significant increases in critical minerals like copper, nickel, cobalt, and rare earth elements, whose production is dominated by just a few countries. We'll talk about the global supply and trade of critical minerals, potential new resources, cost, and the benefits and challenges of expanding mining in the United States to increase our domestic supply. My guests are Nedal Nassar. He leads materials flow analysis at the United States Geological Survey, chairs their Committee on Mineral Information, and holds 3 graduate degrees from Yale.
The uncertainty regarding mining is not, it's not an easy undertaking to get a mine up and running, so there's a lot invested in it. I think what you'll see is that the countries that have a tradition of mining will be the places where the majority of new projects come into play and actually come to fruition and produce.
He's joined by Adam Simon is an economic geologist and professor in the Earth and Environmental Sciences Department at the University of Michigan, focusing on energy and mineral resources.
Are we willing to accept and tolerate mining in the United States, or are we going to say, no, we don't want mining, which in and of itself then means we're reliant on other countries.
Right.
We're talking about a supply shortage within the next 10 years.
I'm Scott Tinker, and I'm an energy scientist. In this episode, we'll discuss critical minerals for energy. Glad you're both here. Let's start with a definition. What are they? What are critical minerals?
So critical minerals, as we define them today, are those minerals from which we extract metals that we use for all types of technology. Anybody who is holding technology, driving technology, using technology is using critical metals.
Anything to add on that, Nedal, just kind of what critical minerals are?
The way I like to think about it is that a critical mineral has to have 2 components to be critical. One is that the supply chain has higher likelihood of a supply disruption, and if there were to be a supply disruption, that would have significant consequences for, depending on your perspective, whether it's a manufacturing company, a sector, a country, or a region. Technologies like solar, wind, electric vehicles, and storage require significant quantities of these non-fuel mineral commodities.
You mentioned EVs. I've read an electric vehicle takes about 600 to 700% more of these metals than an internal combustion engine. Is that about right? About the right scale? Or?
That's right, but it really does depend on the specific battery chemistry. So there are many different battery chemistries.
So most of that's in the battery?
Correct. I mean,
Okay.
that's where a lot of the concern comes in.
Okay.
In terms of which battery chemistry is going to dominate and which battery chemistries uses which commodities.
Okay. Now it's lithium ion, but we may be going, hopefully, towards other kinds of things as technology allows, huh?
Well, within even lithium-ion batteries, there are different chemistries. So there are ones that are high nickel, there are ones that are high cobalt, there are ones that don't need nickel or cobalt.
Okay.
And that's what you're seeing a transition to. As the prices rise for some of the commodities like nickel and cobalt, manufacturers are switching to these alternative technologies that do not require either.
Right,
But
right.
of course, there are downsides to that, right? So
Sure.
the lithium iron phosphate batteries, for example, don't have as much energy density. They are cheaper, they are safer, but they don't have the necessary density for long-range vehicles.
So you can't drive as far on the
right.
same weight.
That's right.
If you will, yeah. Yeah, nothing's perfect.
That's right.
Trade-offs and
There are
everything.
trade-offs.
What's happening in the lithium market, just specifically lithium? What's going on in the lithium market?
So around 2015, prices started to shoot up. So miners around the world started to ramp up production, especially in Australia. So much so that we actually ended up with a surplus and prices actually started to go down. That's changed again, and prices have continually risen, something on the order of 900%.
So the electric car that I'm driving now could get more expensive?
Well, higher prices are a significant concern. And I think what you're seeing today are manufacturing companies working directly with both miners, refiners, and recyclers to secure their supplies. And we're seeing that because they are concerned about the mineral commodities that are used in vehicles, for example.
Right. You mentioned wind and solar earlier. Do they use these critical minerals?
Absolutely. So when we think about an infrastructure that relies entirely on wind turbines or solar panels, we think about onshore and offshore wind turbines, and for every megawatt of capacity that we build with wind turbines, we're talking about the need for anywhere from 5 to 10 tons of copper.
Per turbine?
Per turbine. and we imagine hundreds of thousands to millions of wind turbines around the world, what that means is that that is going to cause a significant strain on copper supply. And that's only copper.
That's just the copper.
Then we talk about, for example, rare earth elements, which right now are 100% produced in China. They mine 60% of the rare earth elements in the world. They produce 100%.
So process it.
So processing, exactly. So making the final product. And we use rare earth elements to make magnets in motors, and those are critical for the ability of wind turbines to produce electricity.
But that's not all that has to be mined. To get that much copper, how much stuff am I mining? I mean, there's rock around this, right?
That depends. The total amount of rock can be anywhere from 2 to 3 times the amount of copper to several hundred times the amount of copper, depending on what the concentration of copper is in a particular mineral deposit somewhere on the planet.
What do you
I was just
thoughts
gonna
on
add,
that?
we did a detailed study of that, looking at what we call the rock to metal ratio. And what we saw is a significant variation both across commodities. So you have precious metals like gold and platinum, where it's millions to 1, right? Gold is about 3 million to 1. For things that are earth abundant, like iron ore or aluminum, it's closer to 10 to 1.
Okay.
Right? But there is variability, about a couple orders of magnitude, even within a single commodity, depending on where you're getting it from.
Yeah.
If we go back 100 years, the concentration of copper in rocks that we would mine, it could be on the order of 10% copper. You know, now when we're looking at major mines around the world, we're talking about copper concentrations that are somewhere between about 0.1 and 0.5 weight percent copper. And that allows companies to make a profit. But as those concentrations get lower and lower and lower because we mine all the good stuff, then that requires costs to go up so mining companies can actually be profitable.
Yeah. You're taking these things from the earth, and we extract oil and gas from the earth. And it's an interesting analogy. You find the easiest oil first, where it flows and great deposits. And as you go down that kind of pyramid, it gets harder and harder.
And speaking of oil, we typically think of oil as being highly concentrated geopolitically, right? But if you look at it, if you combine all the production from OPEC countries, they control about 36% of global oil production. Compared that to lithium, cobalt, and rare earths, the percentages are much higher. 60% of rare earths are mined in China. 70% of cobalt is mined in the DRC.
Interesting.
And 80% of lithium is mined in Chile and Australia. So a lot of these are very, very highly concentrated in a few countries.
I want to make sure I'm unpacking this right. Limited geographic mining or source for those things, extracted. A lot of that is then processed in China. What does that imply in terms of supply chains?
You know, right now, if you look at all of the battery metals, China controls the final production for all of them. So the lithium that's mined in Argentina and Chile, that lithium ore is shipped to China for processing. The lithium from Australia is shipped to China for processing. The cobalt in the DRC is shipped to China for processing. And now we want to see this significant increase in renewable energy. And all of a sudden, we're realizing where these metals are located. And companies and countries that control those supply chains are essentially sitting on the spigot. So they have the ability to turn on and turn off the metals that we need. And if something were to disrupt that supply, there's no battery manufacturing anywhere.
Right.
And so this brings up, you know, socio-political concerns where the U.S. is constantly monitoring that supply chain.
Yeah, so these supply challenges are real. And again, as we go from millions of cars, tens of millions, to hundreds of millions of vehicles and start to back up wind and solar with big batteries, those supply challenges are not going to get better. How do we start to remedy this?
A lot of what we're doing at the US Geological Survey is through a program called Earth MRI, Mapping Resources Initiative, to try to understand what is really out there so we can get a better understanding of the potential, so the resource potential that's out there, not just for the discovered, but the undiscovered resource potential.
Right.
There are many tactics that can be used to reduce the supply risk. Generic tactics like increasing domestic production, increasing recycling, securing trade ties, stockpiling. And the U.S. government is doing many of these actions under various legislations and programs that are out there, and it's moving in the right direction.
Right, and you know, Nedal mentions mapping. Our exploration for these resources now has become very sophisticated.
Yes.
When we're doing exploration in various parts of the world, we're using very sophisticated satellite measurements, right? Airborne measurements, looking for anomalies in the subsurface. So, you know, I teach my students this is similar to getting an X-ray or an MRI. We're seeing companies now using machine learning So taking data historically and allowing computers to sift through massive amounts of data to figure out, okay, where might we look for a particular resource? And then importantly, each time we find a given resource, it's an incremental addition to the total that we need.
Are there issues with this mining on the water, on the land, human rights, things like that? How do you see that?
My observation of mining companies globally is that their intent is always to treat their workers fairly, to pay a living wage, and to minimize their impact on the environment to a level as close to zero as possible. And I contend, based on data, that 99.9999% of mines do that. But as we often hear in the news cycle, if it bleeds, it leads. And so when there is an accident or a disaster, and they do occur, that's what plants the seed in humans' minds to think that that is representative of every mine on the planet.
So these big international mining companies uphold a certain set of standards. I mean, there are places where the human rights are violated, are there not? And
So there is quote-unquote artisanal mining in the Democratic Republic of the Congo.
artisanal.
That's what they call it, artisanal and small-scale mining. If you look at global production, there are very few commodities that have a significant share of global production that is from artisanal and small-scale mining. Typically, those are tantalum and a little bit of cobalt, not much.
Okay.
There's an act in the United States Congress called the Dodd-Frank Act that looks at 3 TG metals, right? So tantalum, tin, and tungsten, as well as gold. Those are the ones that we care about, and that companies need to report that they are where they're sourcing these commodities from.
Okay.
The best estimates we have are that in 1 out of 3 smartphones that Americans use, the cobalt in that smartphone, it was mined by children.
I have to disagree. I don't believe the number is that high. I think it's much, much lower. Most of the cobalt is large-scale companies basically looking for copper and cobalt together in large mechanized facilities, not artisanal mining.
Is it hard to get good data here?
Absolutely.
Yeah.
I mean, by its nature, artisanal production is very hard to get data on because they are very small operations that are, in remote areas, and it's very difficult to track that.
But encouraging to hear it might be trending away from that towards that.
I hope it's less than 1 out of 3.
Yeah. This concept of doing everything somewhere else, whether it's drilling for oil and gas, mining coal, nuclear power plant, mining the things we've just been talking about for this clean energy economy, let's just do it somewhere else. What's it going to take to permit and open new mines in the U.S.?
It's going to take a mindset change for people and groups that are strong advocates for renewable energy and simultaneously strong advocates against mining. They want everyone to drive a battery electric vehicle, but they don't want to allow any mining to build those technologies. I'll give you the example, the state of Maine in 2017. The state of Maine banned hard rock mining.
Right.
A ban. Simultaneously, they want to become 100% reliant on renewable energy. There is a lithium hard rock mineral deposit in Maine that would produce enough lithium for every vehicle in Maine to be a battery electric vehicle. But the citizens of the state of Maine will not allow mining.
Right.
And you can't have it both ways, right? There has to be some give and take. So are we willing to accept and tolerate mining in the United States where, in my opinion, it is done as well, if not better, than anywhere on the planet? Or are we going to say, no, we don't want mining, which in and of itself then means we're reliant on other countries?
Right. So where's it going to grow outside of the U.S. for these things? Where do you see that happening?
So I think what you'll see is that the countries that have a tradition of mining, that have the adequate infrastructure, the labor, the skills, the geological knowledge, will be the places where the majority of new projects come into play and actually come to fruition and produce.
Examples of that, some countries?
Australia, Chile, Argentina.
Africa?
Sure.
What are the challenges to that happening there?
The uncertainty regarding mining is not, it's not an easy undertaking, right? It takes decades, it takes millions, if not billions of dollars to get a mine up and running. So there's a lot invested in it. And if demand fluctuates, if prices change, that could really derail a project from moving forward.
Okay.
Yeah, and I think that's something the general public doesn't fully understand and appreciate. We tend to think of money in terms of the overnight cost, right? What do I need today to buy something to have it tomorrow? Mining companies globally, wherever they're mining, they're looking at 10, 20, 30, 40-year timeframes. So one of the challenges for mining companies is that they have no say on the price of any particular metal commodity.
Right.
So if I am a company and I mine copper, I don't control the copper price. That copper price is determined by people that buy and sell copper futures on stock markets around the world. And yet I'm going to put in $1 billion or $2 billion, again, borrowed money, and hope that my copper mine in Arizona or my copper mine in Zambia or my copper mine in Chile 15 years from now is able to produce a return on my investment.
That's fascinating. It reminds me of the other extractive industries like oil and gas. They get blamed for price gouging.
Absolutely.
Are we going to see mining companies blamed for copper gouging?
We've seen that. Windfall profits tax. I mean, that comes up from time to time, anytime there's a big swing in the price of a particular commodity.
Yeah.
And I think that'll be more important for commodities that are controlled by a few companies or a few countries where there's a very concentrated supply. But for things like gold and copper, again, they're mined basically on every continent except Antarctica. Many, many different companies and countries that mine it. So the ability for them to control prices, they simply don't have the market power.
Right, right. It all mentions some places outside the U.S. Did you have any to add to that list?
You know, I think among countries, for example, with lithium, Bolivia, one of the concerns for international mining companies is this concept we call resource nationalism. And so Bolivia is sitting on a phenomenal quantity of lithium. The concern is that at some point in the future, the country could nationalize that particular mine and you lose your investment. So that, again, adds to the risk that mining companies have to price into their business models.
Yeah, so far we've mostly talked about kind of the third of the surface of the Earth that is land mass. Are we going to go into the deep sea and mine for critical minerals?
Well, what we've seen is that deep sea mining has progressed very quickly over the last decade or so. The International Seabed Authority, which is an autonomous international body that's charged with managing the resources in the deep seas.
Because it's not owned by anybody.
That's right. It's in international waters.
Right.
And so this autonomous body, they've issued something on the order of 30 plus exploration licenses. There's at least one company that's gone through extraction trials. It's difficult to say. There's, I think, a lot of open questions regarding environmental aspects and whether or not we need it or not.
Right. What are the resources down there? Is it real? Have we been able to kind of assess that?
I think there is a lot of potential. Deep water resources now that seem to be of interest would be what we call manganese nodules. And these are nodules that form on the abyssal plain, the deepest levels of the oceans, that contain not only manganese, but high concentrations of platinum and palladium and other similar metals. So the companies that are mining those now, their goal is to demonstrate that they can economically pull those manganese nodules up to the surface and sell them at a price consistent with the market prices for those metals.
And I'm sure as you suck up all the little fish, it cleans them and you put them right back. Or I mean,
absolutely. Again, no mining operation has zero impact on the environment.
Right.
You're going to disturb the ocean bottom sediments, muds and clays and silts. And so a big question then becomes, how does the disturbance of those sediments perturb the local environment in the deepest levels of the ocean? And right now we don't know. So we're sort of at what I would say is a pilot stage of understanding what will the impact be. My understanding of most companies is that they're clearly aware of this. So in order to convince the public that that mining is safe, they're having to document what the overall environmental impacts are and demonstrate that they're less than or certainly equal to mining on dry land.
Right. What's the state of recycling now? Where are we on recycling?
Yeah, I think it's hard to put a number on it because there's very limited data, but what we understand is that if you look across the periodic table, recycling rates are pretty low for most of the elements. There are exceptions, things like aluminum, copper, precious metals like platinum, gold. We do a really good job of recycling them. But for most everything else...
Is that because there's so much value in them?
Absolutely.
Okay, so it's worth it.
It's about economics and it's about logistics. For electric vehicles, as with any vehicle, we tend to keep pretty good track of those. And so I would expect, just like we do with lead-acid batteries, we recycle those with 90% plus efficiency. We would expect to see similar kind of recycling efficiencies for electric vehicle batteries. So one of the things that don't get recycled really well are consumer electronics. And the reason for that is, these enter into our society and then we never see them again.
Interesting. You see similar things?
Absolutely. I think it's just a matter of time until some really bright group figures out, aha, this is how we can separate these rare earths from all the other metals in a smartphone, and we can do it at a cost that incentivizes industry to make a rapid shift to recycling.
Let's wrap some things up. So big picture, what are the main issues going to be with critical minerals in the coming decade?
I think there's a lot of uncertainty, right? There's uncertainty regarding what demand is going to look like, which technologies are really going to win out, are the substitutes going to come into play? There's a question regarding, are we going to be able to diversify supply? How big of a role is recycling going to play? And so these are questions that I think there's a big question mark on those, and it'll be interesting to see how they play out in the next decade or so.
Yeah. What's our plan of action to address some of these challenges?
It really depends on the mineral commodity in question. So for some mineral commodities, this could be we need to have more domestic mining. For others, it could be the lack of smelting or refining. It could be that we can just secure trade, right? Reliable trade partners. Perhaps the issue is relatively small and we can just stockpile what we need in case of an emergency.
Yeah. How about you? What's your plan of action?
I think I would work to create more sensible policies that impact mining in more developed countries, recognizing that if the goal is an energy transition away from fossil fuels to one entirely reliant on renewable energy, we have to mine to get there.
Right.
So when we hear the Biden administration talking about union jobs, right? I mean, what a way to bring new jobs into various parts of the country, right? If we're mining copper and nickel in Minnesota that we need for battery electric vehicles, if we're mining lithium in Nevada that we need for battery electric vehicles, in the state of Idaho, we have what we call the cobalt belt, mining cobalt that we need for battery electric vehicles. And we used to do this. Yeah. And I just don't think when we look at the average level of understanding of the criticality of our supply chain, people understand that we're talking about a supply shortage within the next 10 years.
Yeah. So mine over mind. You heard it here.
I think that's a good slogan, Scott.
Mine over mind. Last thoughts? Anything we didn't talk about that you want to make sure to share?
Yeah. Thinking about these technologies is going to be really important because they are emerging technologies that are changing very quickly. And think about where they're coming from. A lot of these technologies were developed here in the United States. We have an amazing amount of research and development going on, including the lithium-ion batteries. But we're no longer major producers of that technology anymore. Hopefully that'll come back. Right. But this is a situation that we've gotten ourselves into over decades, and it's not something that could be reversed overnight. I think Aldo Leopold once said, one of the major concerns is people think that milk comes from the store. We need to educate the public to let them know that these mineral commodities come from Earth.
Right.
And we need to be able to be good stewards of them because we are paying the environmental burden to extract them. And we need to keep them in the cycle because they can be recycled forever if we are able to maintain them.
Yeah. Can we change the mindset, Adam? You've committed a life to education. Are we there? Are we getting there?
I think we can. I'm seeing progress. In my 20 years in academia, I've taught thousands of undergraduate students at multiple universities who are incredibly bright. And when you make them aware of the resources that power their lives in every possible way, and you encourage them to appreciate the challenges and that we have to make choices, then I think education plays a really important role.
So knowledge, education,
and appreciation.
And mindset.
Right. Appreciation for the resources that make society so amazing.
Right. Thanks to you both. This was terrific.
Thank you, Scott.
We learn there will be a massive increase in global mining for the critical minerals and rare earth elements to make solar panels, wind turbines, batteries, and other new technologies. Processing of these materials is concentrated in just a few countries, about 80% in China, which creates security of supply concerns and higher likelihood of disruption. The mining of these minerals is more broadly distributed, but there are still issues with child and forced labor, as well as significant environmental impact. Mining will likely expand internationally, while others will look to new deep-sea finds in international waters. Ironically, in the US and Europe, groups in favor of solar, wind, and batteries are often against the mining that would provide the metals and minerals for them. Our experts agreed we need to increase domestic mining, try to bring down the cost of recycling, and increase the awareness of the importance of critical minerals for energy.
Energy Switch is executive produced by Scott Tinker and produced and directed by Harry Lynch. Emily Hooks is the assistant producer and researcher. Editors are Ginny Patrick, Yusef Swachina, and Jackie Kunzler. Matt Aslanian does the sound. Energy Switch is produced by Arcos Films for the Switch Energy Alliance, with support from the University of Texas at Austin and EarthX.